Check, check, check. Excellent, excellent. Good, you can hear me well. Back row, everything is all good. So good afternoon, ladies and gentlemen. Ohayo gozaimasu, and warmly welcome to Tiedekulma, Think Corner. And we're having some really exciting topics to discuss this afternoon for a few hours. So we gather here to listen to the magical word of artificial intelligence, so AI, as we in our friends group call it. And of course, we take in quite a broad term of AI trends. So my name is Claes-Mikko Nilsson. I work for NordicNinja VC. It's a venture capital company here based in Helsinki. I'm doing actively investments here in the Nordic Baltic scene. I'm really, really glad and excited to have a very pleasant and informative group of intelligent people from all the way from Japan visiting us here in Helsinki today. So there's a delegation of 20 people from Tokyo University, led by our professor Yutaka Matsuo, who's now bringing all their expertise related to artificial intelligence and now opening up the dialogue, benchmarking, exchanging thoughts what related to AI. As we know, AI is quite a new topic still. What is AI to be defined? One of the discussions we had this morning was of the Finnish professor related to AI defined that what is AI? It is still, as we have some issues as a humankind to define what is intelligence. So more or less, if you show and define what is intelligence, AI is the artificial part of that. So more or less, we're building on having this kind of a digital area and AI related. So good. But without further ado, so we are arranging this event and open discussion. We hope you can join in and feel free to be active. You can use the hashtag AI Trends. So if you have any questions related to Twitter, we're happy to grab them from there. This event is arranged together with FIA, the Finnish AI Accelerator. So we'll also be happily supporting this. We'll be giving more details later on. And then the Finnish Center of AI as well. So we have the Finnish AI ecosystem quite well mapped by these two organizations. And of course, we're happy to support them with NordicNinja. But let's quickly about the program. So we have, as mentioned, 2 hours to discuss artificial intelligence here at Think Corner, the open space to discuss anything related to research and academic findings. And hopefully we'll find more interesting discussions related to AI to come. From the short teaser is that we're going to open up with the keynote by Professor Matsuo, and discussing the AI trends and a short overview as what the information we have related to what might be coming. We'll have a fireside and discuss that in more depth with our managing partner, Rainer Sternfeld, as well. After that, from the second part, we also have of this very exciting delegation. We have also a very special guest joining us. So we have the President of PKSHA Technology, Dr. Uenoyama, joining on stage. And he's one of the early students of Professor Matsuo, but he's also been doing one of the first AI-related companies that's been publicly listed in Japan. So he has the massive background and understanding of actually what it is to build based on artificial intelligence. So we're going to have a keynote related to that and a panel building on that together with Faya and then Peter Sarlin from Silo AI. But good. But before we let the keynotes join in, we're quick update about the activity. So as mentioned, NordicNinja, it's globally one of the first funds to actively seek growth-minded people related to AI. So of course, we're very excited to find this in the Nordic Baltic scene. So NordicNinja, more or less linking up and then doing artificial intelligence is one of the big parts of our investment topic and theme. But what might be interesting is for you to what we gathered so far and contributing to the community here in the Nordic and Baltics is that Japan, it is so that we have the so-called the feeling and experience of Japan as related to startup. It's Softbank, and there's a little less that we know here in the Nordics what comes to. So there's a little bit of a gap. But oh boy, do we have more information available. So one of those opportunities is the Japanese investments in the startup level. So we had so far published, oh, that's great font. So let's stop and read it here, no more or less. So let's just jump onto the next one. So there's a website published, JapaneseStartupInvestments.com. Very simple, quite long, but JapaneseStartupInvestments.com. So it's summarizing all those almost 50 startup investments that done by Japanese corporations or investment organization, worth almost 3 billion. Almost 3 billion has been invested since 2010. So there's a massive activity by Japan as well related. And of course, AI is one of those big interest areas. So that's something you can check out. You can find that also on NordicNinja.vc. And something new that's just been published a few days ago is the summary of Nordic as well. And this is for our Japanese guests as well. So what is the startup ecosystem in the Nordics? So there's a new website also published to summarizing the Nordic scene of startup activity. And what's interesting, this will also be published in Japanese within February as well. So very soon coming up to your home doors. So we don't have the longer one, but NordicNinja.vc/AI, you will find that PDF there for you to download as well. Summarizing quite well the activity so far, Nordics and the Baltics. Good. So please use those hashtags AI trends if you feel any interest to share that with the community. But great. So I think it's without further ado, it's time to jump into our first keynote. So as mentioned, Professor Matsuo, so is all the way from the Tokyo University. And his background, as he's also in addition to his professor work, he's one of the most recognized AI experts in the world when it comes to his knowledge and publications. He's also the president of Japan Deep Learning Association, JDLA, and a board member of Softbank. So we're very excited to have these smart thoughts now being shared with us. So give a warm and big applause to Professor Matsuo, ladies and gentlemen.
Yeah, thank you very much.
And welcome. And here's the clicker, and that you go. Okay. And for any pointing there. Yep. Thank you so much.
Thank you. Thank you very much for the kind introduction, and good afternoon, everyone. I'm very honored to be here to share what is happening in the AI scene in Japan. Maybe my view is a little bit limited, but I hope this will help you having some insight. As he just introduced me, I am a professor in the University of Tokyo, and also I am director at Softbank Group. And we are doing a lot of research related to web, big data, and also deep learning. And let me a little bit introduce our lab activity. Our lab has 4 kinds of activities. One is fundamental research, the second is education, third is collaborative research, and the fourth is incubation. So we are doing everything within one laboratory, which is, I think, very rare as a university lab activity. And we are providing lots of education to the entire university. And this is actually the number we taught. So far, we taught in total more than 3,000 students in 5 years. And and also we are publishing some books, translation. There is a very famous deep learning textbook. We translate it into Japanese. And also we have some TV program to educate people. And because we are educating many students with latest deep learning and data science, some of them makes their own startups. So around our lab, there are more than 10 startup companies, and among them, 2 companies are already listed. One is called PKSHA Technology, which is led by Uenoyama-san. He will talk later. And also we have another company called Gunoshi, which is a news curation service, which is also listed. And because we want to encourage the students to make their own startups, and we want to make like a Silicon Valley style district in Tokyo. And as a part of educational activity we established association called Japan Deep Learning Association. So its member is the AI startups. They are doing the deep learning business. And many traditional companies like Toyota, Yasukawa, Mitsui, Sumitomo Bank, Nomura, Hitachi, they are supporting us to educate people with this deep learning technology. And we are doing some tests. And there is two kinds of tests, G-test and E-test. G-test is for business person. So we ask the people whether they have a certain knowledge about AI deep learning. What is deep learning, what is CNN, what is dropout, and so on and so forth. And E-test is for engineer, so we ask them to have the proper knowledge on programming and also the mathematical knowledge. Okay, this is the gathering of the successful examinees. And we want to make it more global, so we want to make the English version of the test in the near future. Okay, then I want to share with you about the current deep learning and the future deep learning. And as you know, deep learning is a very innovative technology. It's a neural network with many layers, and we have three very famous professors: Jan LeCun, Jeffrey Hinton, and Yoshua Bengio, who got a Turing Award last year. But don't forget about the Japanese researchers. Shunichi Amari, he's very famous in the 70s, 80s, who invented many techniques in neural networks like natural gradient. And Kunihiko Fukushima, he is also a kind of father of CNN. And so convolutional neural network was his invention. And I think there is a three-stage for the deep learning development. At the current moment, we have many applications using recognition. So we have technologies like image recognition and voice recognition. So we can use that to catch some criminal people or face recognition or such kind of things. And then we will have the phase of the mastery of movement, what we call. So robots, machine can move very proficiently in the very near future. And then there will be the phase for understanding the meaning of words. So AI can understand the meaning of words, in my guess, in 5 or 10 years. And this is my prediction of technology development. Actually, this illustration is what I depicted in 2015, so 5 years ago. But I think prediction is very correct because currently we have the recognition phase, and gradually we are moving toward the mastery movement phase. And then there will be the comprehending language phase, I guess in 5 to 10 years. And as the technology develops, there will be more and more industry application and impact to the society. Because Japan is very strong at robot and machines, I think the second phase, mastering movement phase, is a key for us, Japanese. So I think there could be many applications using deep learning for agriculture, construction, food processing, manufacturing, housekeeping robots, and so on and so forth. Because Japan is a very aging country, so we are short of the labor. So we want to automate many jobs. So I want to show you some examples. This is a very standard YOLO object detection program. So we can use this kind of technology for robots and machines. And then we will have various robots that move around the room or the machines that will dig the hole. The left bottom the picture. This is the house cleaning robot by a Japanese startup named Preferred Networks, and it can pick up things and put to the right position. So if this technology is come true, when we go back to the home, everything is very clean. So that is a very good application. And the right side, I will talk more about this. So this is an automated construction machine. Looking at the controlling chair, you will see no people inside. But the machine can, dig, pick the sand and move to the other place automatically. And there is a strong need for such job because, for example, if we want to build a house or a building, we should, reduce the height of the land to 30 centimeters or 50 centimeters. It's a very, tough job. But if this job is automated, we can make the machine do this kind of job all through the night. So the next morning, we will find that everything is done. So this is another view. So you can see that there's no people inside, but there's some hardware to move the lever. And by using cameras and deep learning, we can detect things. We can catch the hole, sands, and then we will, the AI will, send the signal to the machine. And of course, there are many kinds of, tasks. This is a rather simple and easy one, but there is more and more difficult tasks. And we are challenging to that. Sorry. Okay, and this is another example, what we call the deep cabbage project. So using a robot, we will pick up cabbage. Do you understand why this is important? Because maybe there is a salad in the shop, but every salad, the people are making it. Because picking up the certain amount of cabbage or lettuce, that is very, very difficult task. Because sometimes it's very sticky and the shapes are different. So it cannot be automated so far. But we want to make it automated. So how? This is the one. So we use robot hand, and sorry for the Japanese. The AI will learn how to pick up the certain amount of cabbage using the reinforcement learning. So it is very, very difficult, and we tried many different types of hands, because the good hand to hold cabbage and good hand for running is different. So that is a very important insight. So if we want to make robot machines learn something, we have to make the hardware easy to learn something. And you can understand that the robot is picking up a little bit larger portion, and then using the finger, drop some portion to adjust the weight. And this is collaborative work with a robot system integrator company. And if we can, use this technology in the factory, the many kinds of tasks could be automated. And this is a learning curve. So as iteration progresses, the amount to pick gets more stable. And only 2 hours is required for the learning, for the training. Yeah, okay. And we can imagine there's more, way to go, because cabbage is the one of the easiest one. But for example, the pasta, picking pasta is difficult, and picking more sticky things is more difficult. Okay. And I shared 2 examples: construction machine and food processing machine. This kind of machinery, integrated with deep learning, has a huge potential for automation of our, human labor. So we can make many things like a cooking robot, or the disaster prevention, or many things. And I think deep learning with manufacturing is a way to go for us Japanese, because we have many automotive companies, industrial robot companies, and we have aging population, so the combination should be this kind of solution. Okay, and this is the second stage, and in 5 to 10 years, I guess there could be AI that can understand the meaning of words. So there has been lots of discussion: what is meaning, what is understanding, what is intelligence. But my hypothesis is that the human intelligence consists of two-layered architecture. So the lower layer is what we call the sensory motor system, and the upper layer is called symbolic system. And the lower layer, we call it animal OS because we share the system with other animals like dog, cat, monkey. But the symbolic system we call language app. So language application is constructed on top of the animal OS. And actually, there is the Yoshua Bengio, the very famous professor of deep learning, had a talk last year, December, in a conference called New Lips about what is the human intelligence, and he said that we have two separated system, the two RNN system, and many philosophers and psychologists said the human mind consists of two kind of systems. The famous researcher Daniel Kahneman, who got a Nobel Prize, said system 1 and system 2. There are two systems in our mind, and system 1 is very fast, system 2 is slow. So I think this two-layered architecture is correct, and I think there could be there is a technology that can realize this kind of two-layered intelligence. And I think there will be AI that can understand meaning. And my hypothesis is this. So I think meaning refers to drawing a picture in our mind using a language. So when you hear a sentence like, there is a cat on a chair, you can write, you can draw a picture in your head. You can imagine the scene, a cat on a chair. So it can be realized by a generative model. And this is, I think, this is the how we understand the meaning. And young children actually draw a picture in their head, but as they grow, the picture gets more and more abstract. So we adults don't think we are drawing a picture in our head, but it's something similar to picture, more abstract thing. And besides image, we are handling sound, touch, and other sensor signals. Also, we are handling the actuator signals like motor system, the hand or foot. So, rather than a picture, we should say it's a body of sensory motor information reconstructed from a language. So I think by progressing the robotic research, we would have some algorithm to reconstruct the body of sensory motor information from a language, from a sentence. So that means the AI can understand the meaning. And with this algorithm, maybe we can make the AI assistant that can understand the meaning and do things, or we can make a program that will do some paperwork. So there should be a very huge impact to the industry and society. Okay, so this is a summary of my talk. I shared the AI deep learning education in University of Tokyo and also the startup ecosystem in Hongo area. And I talked about JDLA. And I shared two examples, construction machine and food processing machine as an example. And the potential, I mentioned about the potential of deep learning integration, deep learning integrated to the robotics and machinery. And there could be the AI that can understand language in the future. Thank you.
Thank you very much. And we'll continue the discussion more in depth. So thank you very much. So maybe, Professor Matsuo, you can take a seat. And we're going to join the stage with our managing partner, Rainer Sternfeld, who is more or less going to do the more in-depth questions. So Rainer, he's our Ninja team member as well. He's been just returned from Silicon Valley after some serial entrepreneurial activity going around. So we're going to more or less have him impact and share his vision on the AI and have a good discussion with Professor Matsuo. And for those, so this will be live streamed and recorded. All the material will be shared as well for you to have a look on. So it's currently Tiedekulma, Think Corner. If you Google that, you can find that live stream. And more or less then AI trends, you can use that hashtag, and more or less NordicNinja.vc/AI will save all the material there. Thank you. But without further ado, let's give Rainer Sternfeld a big hand and applaud for joining the stage.
Thank you.
Good.
Thank you.
And there.
Hey. Hey, good to see you. Hello, everybody. Thank you for the presentation, and I'm very much looking forward to this conversation. I've prepared some questions, and hoping that we'll have about 30 minutes of discussion. And if you have any questions, we can leave those in the tail end of the conversation. Maybe yes, a few words about myself as an introduction. Trained as a roboticist in Estonia, started working on unmanned vehicles, but kind of very quickly turned to data and data management and data exchanges and data economy in general. And for the past 8 years I spent in Silicon Valley. I've been building companies and organizations for 18 years, and so kind of going from atoms to electromechanical systems to sensors to data and to business models. It's been a very interesting journey, and so maybe I'll start out with a kind of a funny joke, since I was kind of introduced as coming back from Silicon Valley. So in Silicon Valley, you have this joke that when you pitch to investors, you talk about AI, and when you pitch to customers, you talk about machine learning, and then you pitch to engineers, you talk about regression analysis. So there's this, increase of use of the word AI. You sprinkle AI everywhere, and it sort of works as magic to capture people's imaginations and attention. But it's not that easy. And maybe I want to focus today on the problem or the aspect of control in AI, so that with more general public topics. And one of my favorite quotes when I was a student 20 years ago was by a now passed away futurist, James Martin from the UK. He wrote a book about, it was called The Meaning of the 21st Century. And in that book, he argued, which is very much true, I believe, today, he argued that in the 20th century, humans learned how to invent stuff. In general, we would come up with something, we would figure out a way how to make it happen. And then he argued that in the 21st century, humans have to learn how to control all the technology. So in other words, we can have the technology, but it can make a lasting impact, in which we will have to then simulate beforehand, before we maybe invent something and then go, oops, that really didn't work out for the best. So maybe we can start with in the past weekend there was a Munich security conference, and there was a panel on AI risks moderated by the current Estonian president, Kersti Kaljulaid, and it was between two big countries. One was representatives of two big countries. One was former CEO and chairman of Google, Eric Schmidt, so representing the United States, and the other side was Fu Ying, who is the chair of Foreign Commission of China. And it's a very interesting triangle. And so one of the issues regarding AI and risk is obviously with big governments involved and big spending involved is regulation of AI. And there was a debate about regulating AI towards prematurely towards an early grave, meaning that some sort of regulation could stop innovation and technology innovation, and therefore it should be regulated towards safety and not so much as limiting technology's abilities. If you think about Japan, what is your view in that debate?
I think in Japan, AI employment is very slow. So many companies, government and the public sector don't use AI, digital technologies, not so much. So in Japan, I think the pushing the technology forward is a good thing. But as a whole, world, I think there is two kinds we should very careful about. One is the military use, and another is the privacy issues, like the facial recognition system can, detect every moment of the people. So those two issues, maybe we should discuss more. Yeah.
Mm-hmm. To me, I've been going to Japan for the past 13 years, and to me, Japan seems very much in the same philosophic mindset when it comes to privacy as is European countries. So you have three models, and please confirm or debunk it. So the three models right now that we see in the world. One is the European model with GDPR, with every bit belongs to somebody, so therefore it needs to be governed. In the US, you have data capitalism, so people are like, yeah, fine, sure, take my data, and then companies capitalize on that. And then you have the Chinese model where everything you do online, there's a pipe going to CCP. You can cut that out. I guess it's live. So, am I correct in saying that Japan is following the same footprint, or is Europe following Japan?
Yeah. I think the Japanese attitude toward AI and data is very similar to European one. So maybe we are making very strong connections to European countries, and what I think is that maybe we have to have new form of freedom or right in this digital age. For example, maybe we have the right to make our mind by ourselves. So for example, the marriage or job hunting or such the life event, we have to decide by ourselves, and not intervened by the advertisement or so this is a new form of human right, I guess. So there should be more and more various forms of new kinds of human rights in this age. So that is one thing I'm thinking. The another thing is like China, if the government has a strong power to collect the data, maybe that will, make the entire country stronger in some sense. And as a Japanese people, having less privacy is not a good thing. But if the country will get stronger, maybe that will be the new standard for us. So
I think that presents a very interesting dialogue in general, that these different thought models come from different cultures. So they're all objectively right, depending on which perspective you're looking at from. And so if we talk about existential risk or AI risks in general, there's this vision of singularity, and then there is this question of human control. Where is the human in the process? How do you maintain human control in the age of deep cabbage, for example? So what do you think about that?
Actually, I don't take very serious about such an existential risk. Because as AI researchers, it is very, very far away from the current technology level. We don't know how to, put some objective into the program, or how to, govern people. So it's very, very hard, and I can't even imagine that kind of program. So I don't have any concern about that at the moment. But maybe in the long run, we have to discuss which scenario is good for mankind.
Yeah, and this my devil's advocate question was asked intentionally, because I think one of the interesting topics with multi-generational development is that nobody is responsible. Like if you think, there's a book about food produce by Joe Robinson, where she takes it's a lady in California. She takes apples and bananas and things available in nature, in farmers markets and supermarkets, and then does nutritional analysis on these different things. And obviously humans have been developing food produce for forever, since we've been around, but nobody's responsible for any of this. And then you do the nutritional analysis, and you see that we've taken out phytonutrients, we've taken out a lot of bitter taste, but it has a function in our digestion system and so forth, and therefore we end up with something that's full of carbs and not so much with very useful things that signal our brain that, hey, you're full, and things like that. And so if we talk about AI and a multi-generational aspect, I very much agree with you that the general AI risks are largely overestimated, but at the same time, it's really hard to predict 30 years out, in the same way like it was very hard to predict 30 years ago where we will be today. And so therefore the question that I have for you, and then it's a wider audience question in general, is that can we really design AI in a safe way against some sort of an ideal society that we all want to see? And then what is that ideal society? And the real question is, in that case, is that how do you govern these types of things that are multi-generational?
Okay. I'm a big fan of the evolutionary psychology. So it says that every emotion has an origin, in an environment where the people are located. So, for example, we taste strawberry very delicious because it has a nutrition in our environment, And we taste something very bitter because it has some poison, bad things inside. So every emotion has the origin in the environment that people lived. And we are the social animals, so we help each other to fight against the enemy. So that's why we have some feeling of some pity, or we want to help others. So in that theory, I think the human happiness, the human justice, the human ethics, all from the environment, the evolution, and the environment that people are located. In that sense, I am a strong believer that the AI will not have such kind of emotion, such kind of objectives. So we human only have that kind of objective emotion and the happiness. So I think we human will use AI for our happiness, but AI will not, do anything by its own. So that's my thought.
I really like, in your presentation, I really liked your two-layer approach to AI, with the animal OS and then the language app. And this generation of AI is particularly good at vision-based systems. Obviously, deep cabbage is a complex problem, more than just vision, but in general, if you look at the development of AI, vision is a particularly good area or domain, because it's also language agnostic. Everybody can work on that, whereas if you were to create some sort of a contextual language based search engine for Japanese or Finnish or Estonian, it would be very difficult. Even in English, that's proven to be quite complex. If we talk about the business of AI, where do you see in the next, let's say, 5 years to 10 years, where do you see big opportunities, in which areas?
It's very difficult to tell because I think AI or deep learning itself does not convey much innovation, but the entire system will change. For example, the agriculture will change because the workforce is a human so far, and it's not so efficient, efficiently planned, or for example, if the farmer will cultivate something, they will sell to the market, and the market will send to the retail, and that whole system is not so efficient. So that inefficiency will change. So the agriculture will change in 10 years or 20 years. The construction is also the same. Construction will change in 10 years to 20 years. The education, medicine, and the food processing, restaurant, that will change, and also the real estate, that will change. But we cannot which aspect, which point the change will begin. So maybe it's the automated cultivation system. In that case, we can use the deep learning, but maybe it could be the more efficient planning of delivery of the cultivated products. So in that case, we just use some data science and a little bit of machine learning. So I think my view is like that. So deep learning or AI itself doesn't change anything, but the whole system, whole industry will change dramatically. And we have to point at in which point the change will start. Yeah.
If we dig deeper a little bit into the business of AI, at NordicNinja we like to very much focus on mobility and digital healthcare and things of that nature, although it's not limited. But in terms of application of AI or investments into infrastructure of AI, it's a completely new type of business as a business. And actually, this very morning, when I was on my way over here from Tallinn on the ferry, I was browsing the recent news, and the night before, Andreessen Horowitz had published a new report on their own learnings about the kind of the early generation of AI-driven businesses, and the business statistics on particularly around gross margin was really interesting, where on-premise businesses like the old software businesses were around 80-90%, and the SaaS businesses around 70 to like 85%, and then AI businesses based on today's kind of development look more like traditional service businesses with maybe gross margins around 60 to 70%, so lower. You have like a kind of a incremental step lower every time. Why do you think that is? Or do you think that it's just an early phase?
Yeah, I think it's because early phase. If the AI and deep learning will become more and more commodity, it's very difficult to get profit by that part. But eventually, maybe the player that took the user interface or user's contact point will have the large profit margin, I guess.
And one of the interesting things that I've sort of followed is that you have this dichotomy where there's on one hand, you need a lot of data to make decisions. So AI today needs a lot of data to make decisions. And at the same time, it doesn't need all the data to make efficient decisions. And there's a lot to be said about the quality of data, and then circling back all the way to the beginning of our conversation around ownership of the data and validity of the data, or stakeholder capitalism. As I contribute data, should I also, benefit from contributing the data? Do you see some sort of challenges when it comes to coming out with new businesses today, when it comes to the idea of controlling your own data versus building a new business model? Well, let's say as control over the data increases, companies will have fewer kind of freedoms to manipulate and work with the data.
Yeah.
So how do you see the kind of the societal model and economic models converging?
As you said, many Japanese companies thinks that data is important, and but when they look at their own data, the most part of them are not useful. So maybe we have to design properly what kind of data we should take, and data network effect is very important. If we get more data, so the competitiveness, the strength will larger, then it has a positive effect. But many data doesn't that kind of effect, because we have a certain amount of training data. So the performance we were like this. So we don't have any more data from this point. So some data has such kind of a network effect, and other data doesn't have. So we have to look at that nature.
Okay. As we have some minutes left, and I want to leave some time for Q&A, maybe kind of one of the questions that I have is what kind of trends in the Japanese startup ecosystem or the development of AI in general, doesn't have to be a startup. What kind of trends in Japanese kind of ecosystem around AI are interesting to you right now?
I think like Toyota, the very large companies in Japan now gradually prepared for the AI deep learning technology. So they made their own AI team inside. Sometimes they made the new new companies, subsidiary companies for AI development. So I think in the near future, the Japanese companies will make some integration of hardware and deep learning, and that is very, the bright future. And also startup companies can help that transition. So with that direction, I think there could be the good future. Yeah.
Okay. Well, I hope your visit here in Helsinki and this week also in Tallinn will give you some interesting kind of potential partnerships between the two regions. Maybe we can switch to questions. Is there a microphone that we can throw around?
Hi, Christopher Lawson. We're building basically a bot that can analyze UX online and to improve websites. You mentioned that you're kind of coupling the mechanical, the movement side of what you could maybe say AI, and then maybe the understanding, the language side. So you're thinking that they're part of the same journey, whereas I think a lot of people would differentiate those, that some would describe the movement, the mechanical elements as quite different from the understanding. So I'm curious to hear a little bit more about that, and especially because Japan has long led in sort of robotics, but I would maybe argue that Silicon Valley has now lately taken a much more software approach to the AI side of things. Maybe you can elaborate on that a little bit. Thanks.
Thank you very much for the great question. I think the real language understanding is only possible through the development of robotics. Because we can understand language because in our childhood, we can understand the surroundings objects, and we can manipulate things. And so we have some sensory motor system in the bottom. And then we will start learning the language on top of that. And for example, if we say, I'm falling in love. So it's falling. So why do you say it's falling? Because we use such kind of analogy for the spatial recognition. So we have some spatial model inside, and using that model for language understanding. So we overcome hardships. So why do you say overcome? So it's a analogy. It's a mental model. So my belief is that the real language understanding is only possible through the robotics development.
Any more questions? There's one here. And
hi, thanks for coming. My name is Alexander, and in your picture of human brain as a separation of animal OS and language app,
Yeah.
right?
Yeah.
I don't see room for anything like consciousness. So where do you fit consciousness there, and do you even fit it? Is consciousness a real thing? How would you define it?
Okay, thank you very much. Thank you also for the great question. Consciousness belongs to the language app. And so there is an interaction between the animal OS and language app, but sometimes language app cannot control everything because the animal OS does their own job. So language app, because the language app is made to contribute to the long-term planning originally. So it is very good at handling the sequence of actions. So the language app sees the world from the sequence of actions. And, but something different will happen in the animal OS. So there is a difference between what the animal, what language app want to do and what the human really doing. So that kind of difference is maybe I think the point we feel about the consciousness. So it's a very vague answer, but I think in the near future we can make such kind of algorithm to show this is this part is what we call the consciousness. Thank you very much.
maybe in your defense, saying that it's a complicated question to answer, there's in neuroscience this whole debate today going on: what is mind and what is brain? The separation of the two, or whether there is a separation of the two and cannot be done, or can it be done? So it's a very interesting topic, also in the realm of AI, I think. Any more questions? Maybe we can have time for one more. Last one.
It's kind of a two-part question. You had 2025 for understanding. Do you consider the speed of NLP and like language understanding moving faster? And then also, what do you think about behavioral modeling and how does that affect understanding?
Sorry, I didn't catch.
Behavioral modeling,
Behavior, okay.
so you can predict behavior.
I think I don't know about the exact timing. So I think maybe in 5 to 10 years we will have the real language understanding system. And in my opinion, almost all part is possible even now, but the integration is very difficult. So if we maybe, I don't know, but Google or Facebook or some other lab will put more money on that, it will be much faster. And And after language understanding, there will be more and more things to go. Because, for example, we understand math formula. What is this? We can find the physics formula. So what is this ability? So that kind of thing will follow the language understanding. Yeah. Maybe I'm not answering.
It's okay. Yeah. I mean, we can continue this conversation offline. I think we're out of time. Thank you so much, Professor Matsuo, for the keynote and for your perspective. Thank you for the audience.
Thank you very much.
Thank you.
And if there's one more question, as the Professor Matsuo, if it's okay, if surprisingly, Softbank has a special place in the hearts of Finns, especially thanks to the Supercell story and games. So there was a question related. So if that would be the last, more or less. So as Softbank, we're related to game investments and to all that. So how would you summarize your discussion as a board member of Softbank and related to AI? Is that not an easy question?
Yeah, that's very difficult to answer. But I think the macro direction is most important. Let's think about we are in 1990s. What we do is just to invest in internet. So there is a short-term up and down, but in the macro, a long-term perspective, what we should do was to invest in internet. The same thing is true for AI at the moment.
Very good.
So,
it's a big development. And the actual question, so what you've seen, what has made you most exciting? Maybe, I'm not sure how much you can share from those board meetings at Softbank, but yeah, what has made you most excited related to AI?
Yeah.
This is almost like roasting, no pressure.
The board meeting is very, very exciting. So every board meeting we have very, very good news or very, very bad news. So, it's very exciting. Yeah.
So a lot of emotions there. Okay, yeah. I think we're going to have those closer questions and discussions during the network. So thank you very much. Yeah. Let's give a big applause. Thank you very much. All right, thank you very much. And we're going to continue now on the next level as we were discussing more or less the AI trends and what are the opportunities on the global level and where it's going. So now we're going to head into the part of actually building related to AI. So we're super excited, of course, to have one of the builders of the first publicly listed AI-based company. So PKSHA technology, so developing algorithms within this field. And from that, we have one of the early students of Professor Matsuo. So Dr. Katsuo Uenoyama is going to join the stage and share some of those views of building and developing related to AI. So big applause, ladies and gentlemen. Very good.
Yeah, thank you for introductions. And my name is Katsuya, CEO of the PKSHA Technology. And okay. Today I presented two topics. One is our company overview that's really related to the Japanese AI landscape. And the other is that more big picture of the software market in Japan. That's maybe informative because Japan is a really aging company, and that's really related to the AI because lack of the workforce. So. Yeah, and firstly, I found my company in 2012. Before that, I was a student in Matsuo Labo, and after that, I found my company. The timing is 2012. That's the same timing is deep learning breakthrough with occur and start spreading to the academia field. And this is the outline of our business model. Slightly busy slide, but let me explain more shortly. We have the two components of our business. One is that algorithm module business, which is a semi-customized based solutions for enterprise company in Japan, like Toyota or NTT or mega bank or their huge. We didn't focus the business domain. We will focus the size of the company. This is the first component of our business. And the other is that algorithm software business. This is a totally same as the SaaS business, software as a service with the algorithm. And I have a couple of the software, and these two business have the strong synergies each other's. And now our company became public in 2015, and the number of the employees are around 250, and mainly engineer. And roughly revenue is this year is around $60 million US. So this is our business overview, and this is the business domain focus, and we have the three focus. One is mobile computing, and the other is the imaging device, and third is embedded AI. But we develop the algorithm internally and supply to the client from the server side mainly. And our algorithm is mainly machine learning based, NLP, voice recognitions, and image recognition kind of stuff. Today's and my company's vision is giving shape to the software of the futures. And today's I will explain. I don't explain the detail of my company. This is but this slide is really important, I think. And this slide makes 3 years ago. And let me explain this slide. And now is a algorithm era. We say that we are developing the algorithm, but in order to understand what's going on now in AI field, the good way is that look through the history of the software itself. So let me explain each step. And the first step is that the enterprise era. And this is a first computer around 1960, and the name is the mini computer. So this is huge for me, but in this timing, the name is really mini computer, and many researchers calculating using this device. And the first phase is that the size of the computer will becoming smaller, obey to the law of the Moore. And in this case, each computer didn't connect to each other. So second phase is that this one is that the internet era. Each computer device will start to connecting with each other. And this is a visualization of the internet in the 1990s. And each computer connect to each other, and the people easy to access to the internet and document data. Now we can't imagine the lifestyle without a search engine, but before the web, computer didn't connect each other, right? And why I explain this history is that what is AI and what will the future is a good way to understand is that back to the history, right? And this is a 1990, and this is a visualization of the web in 2015, and the structure is slightly changing, right? And two change. One is color is red is the Chinese web, and blue is the US web. So structure become more clusterized each other, which is largely driven by the social media. And each web is divided by the language and the thought. And this is important because, for example, in Japan, we have the smartphone, but young people see the smartphone 4 hours a day, and mainly using the social media. But all people see a different image because follow and the news feed is totally different, right? So in that timing, all people see the different page. This is really important in Japan because Japan is an isolated company, and almost all people see the same information. But now, people see the different information. So these days, really difficult to see the mass marketing in Japan, but this change of structure is really important, I think. And this is a really simple diagram of the history. And this circle stands for the computer node. And the big computer node becoming slightly smaller. This is the enterprise of the era. And the second phase, each node start to connect each other. And this is the internet era. And now, is the two things is happened. One is, this is Japanese, but one thing is that calculation inside the computer node become really complex, largely driven by the deep learning. So, just and this is a comparison of existing software and deep learning software. The way to develop the software is totally different. Right side is the existing software, which is written by the engineer. All line written by the engineer. If blah, 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 then blah, 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 like that. So this type of the software is that if input something, the output is definitely the same thing, right? But deep learning-based software is totally different. There's a two steps to develop the software. One is that engineer roughly writes the neural network model firstly, and second, gathering the data and the input to the model. And the parameter will changing, and software will developed. In this way, people easy to develop the complex calculation into the software. This is a big change from the phase 2 to the phase 3. And the second change on this algorithm era is that changes the computer interface. As Matsuo-san already presented a couple of the examples, but deep learning algorithm is use the image data and the sound data. Before that, all computer interface is developed by the, this type of the keyboard, right? So this is a totally different and really big change, I think. So let you show the, just a moment. This is simply demo to the image recognition. The top image is the input data, and the computer easy to segmentation and detect what's going on. So software easy to understand what's going on in the real world. This is totally different from the phase 2 to the phase 3. So I think a lot of the software will flourish in the future because this type of computer interface we can develop now. And this is the other example of the Google makes the deep dream. So not only for recognize the image and the voice, software easy to generate the sound and the image data. So this is one example we are developing in Japan, is that X-ray data categorized by the algorithm. So white image is input data, and red image is output data. And all calculation by the software only. And this type of the recognition type of stuff we will supply to the client. This is one example. And the other product we are supplying a lot to the client is this is a natural This is a NLP product for customer support. In Japan, the working population is slightly declining, declining. But if we divide it by the business domain and area, some field, number of the working force is rapidly declining. So this NLP product is kind of the chatbot, but we will make alliance with LINE. LINE is the biggest media in Japan, and we supply the NLP engine to BPO supplier, and they resell to the product to end user. And the important thing is that all algorithms supply to our server. So every user connect to our product, all data gathering to our server. So Matsuo-san say that data network effect is really important. This type of the way to supply the product is a good way to build the product. And the backend is based on the deep learning net. And, and our product focus for the Japanese language firstly. So the precisely of the algorithm is a procedure Watson or as an enterprise product. So and this is another example of the detector transaction detector. How can I say in English? Is that detects the transaction fraud. I mean, when user use a credit card and okay. Okay, next to the next. Okay, anyway, what I want to say is that giving the shape to the software for the future, that's what we really want to do. And my curious is that how does AI affect the society, and not only society and the company, and our brain itself. Our brain means what I say that every people use a smartphone device more than 4 or 5 hours per day. So definitely our brain architecture is a neural network based. So which kind of media or which type of the software we are using is definitely we rewrite it by the software, right? So which kind of the shape is really important, I think. So we are really excited about develop the algorithm software in the future. This is the first chapter, what we are talking about. And the second thing is that more macro view of Japanese market landscape. And sorry, this is Japanese, but this chart is really important to thinking about how to monetize the algorithm software in the enterprise software market. This is a breakdown of our growth. There is a 3 drivers of our growth. And the left side is that operation becomes software automations. So right side, this chart is that the size of the software market in Japan, and roughly $20 trillion now. And as you can see that the red line is more rapidly growing. And the center chart is that the size of the software from the server side. So now in Japan, around 90% of the software is on-premise based, not the server side. But all software becoming to the cloud server side, and this is the second driver. And the third driver is that software become more intelligent because they're largely driven by the deep learning base. For example, the sound and the NLP or image, this kind of stuff. So these 3 drivers are really important to develop the software AI business in enterprise market. This is one macro view in Japan. And the second thing is that the aging population. So yeah, these days working force is declining. And if we divide it by the working force by area and business domain, this is a top 10 and the bottom 5 business field, which people, working force is a lack of the company needed, compared to the company needed. So a couple of the problem will exist. One is how to cope with aging in certain field, because mobility or some high after retirement business requires many working force, but Japan, nobody has the time to working for that. So, and the other is that call center and retail and restaurant, this type of the business in Japan, Japanese omotenashi, all retail store supplied by the human in person base, but it will become impossible to serving in this way. So my guess is that in 5 years, in Japan, retail store will become changing how to deliver the product to the consumer. So this type of the problem will the Japan specific, I think. So if we think more positive way, this is a chance to develop the future software for lack of shortage of the working force. And a couple of the products we are supplying the industry, mainly the reason why the product is rapidly growing is that this type of the issue. And this is a population pyramid in Japan. Left side is Japan, and right side is the whole world. As you know, that Japanese population is really aging. So in 10 years later, more than 40% of the people is more than 60. But in whole world, 60% is less than 35, which is kind of the digital native population. So this huge gap is a really serious problem in Japan. But from the software developer, maybe this feels a chance to the growth. And what time is it now? 1 or 2 minutes late? Okay. The last slide is that this is a really business perspective, but really important to the why our type of the business is rapidly growing. Maybe this is Japanese specific, I'm not sure, but how to develop the software became totally changed. And existing player like IBM or other enterprise player is in the dilemma of innovations. Dilemma of innovation means if they will imitate that our business model, their existing business will start to slightly shrinking. This means a really important thing, but this comparison is really important to the how to build the business for the algorithm software. There are four reasons. For example, if the traditional player existing software is developed by the horizontal integrated way, means the first player designs a whole overview, and the second player builds a sub-component of the software type of stuff. So during this requires a long time cycle, around half or 1 year. This is definitely the same way to build the construction. So maybe this is a Japanese specific way, I'm not sure, but traditional software was developed by this way. But intelligent software is totally different to how to build, because iteration is really important, and a small team is really important, right? So both software are software, but definitely they're different how to build and how to price for the client. And the traditional player is impossible to imitate the way to supply the product. It is not a technology issue, it is a business model issue. So this is the second important thing when we're thinking about the algorithm software business. Okay. Yeah, maybe. Okay. Yeah. Thank you for today, and yeah, let's discuss further. Yeah.
Hello. Yes, so excellent. So we're going to build on this with a panel discussion. You're going to be joined by two panelists here with you, but maybe further, as we know that Japan and the entrepreneurial culture been very similar to the Finnish one as well, that we had the latest years, the entrepreneurial career for the university students here as well. It's become like almost half of the university students consider becoming entrepreneurs. So how was it with you as well? Was it purely the market opportunity in 2015 to build it up, or what made you take the step towards the entrepreneurial path? What made you an entrepreneur? Was it that market opportunity or just, yeah, what was the final one?
When before we found my company, I did two careers. One is working for the laboratory, and the other is working for the business. So these two types of the skill integrate each other. That is a competitiveness for this type of the career.
Very good. So it was the combination, more or less, of the experience and then the opportunity. Okay, thank you very much. Well, we're going to build on that discussion together. So please feel free to be seated, and your panel will be joined by Alexander Tönner, who is the CEO of Finnish AI Accelerator, and Peter Salin, who is part of the and founder of Silo AI, one of those most prosperous AI-related startups here in Finland, building the largest private AI lab in the Nordics. So very excited. So enjoy the discussions, and we will be all ears. Enjoy.
All right, howdy folks. And of course, Klaus Mikko stole my introduction, so I think we're good to go then. So first of all, Katsuya, thank you for the presentation. I think we're gonna kind of jump actually to the last slides where you talked about your businesses and how you see software business going into AI businesses. And also, I would at maybe this point, Peter, if you would like to introduce yourself and Silo AI, and maybe shortly explain what you do, so we are on the same level here.
Yeah. Thanks a lot, Alex. It's a pleasure to be here, and I think it's an amazing journey that you've been going through in Japan, and there's a lot of similarities, I think, to what we are doing here in Finland and the Nordics. So Silo is a 2-year-old company, a bit more than 2 years now. And at the moment, we have about 70 senior AI experts, and we're building customized AI solutions for customers on top of an existing development and delivery platform. And the background of the company is that myself and 5 other co-founders put together the company with strong ties to academia, and that's what we've been building on. So most of the people also within the company at the moment are with a background in research and advanced machine learning. So with this, I'd be happy to jump into details on how we look at AI and what we believe are the current sort of trends and future trends in artificial intelligence-related technologies.
All right, great. So I was checking your website. I use Google Translate to understand anything, but so you were mentioning, for example, technologies as and also in your presentation as NLP, image recognition, deep learning. So is that kind of the technologies you're focusing on? And could you maybe give us some more concrete examples of specific use cases? But this is a business topic, so we need to know actually what you're doing with those technologies.
Yeah, of course we will focus for the technology stack, but for example, NLP voice and sound, and calculations of prediction or classification or detection, like type of stuff. So, but I think the important thing is that we have the 2 components of the business. One is a solution-based, the other is a SaaS type of the business. And during we do the solution business for the various clients, we will understand which type of the pain and which type of the needs exist. We find out, and then we will start to develop the SaaS type of the business. So, of course, focus is really important, but AI type of stuff, it's difficult to predict the near future, right? So these 2 combinations are maybe Japan-specific, but we are really important thing. We think that. So.
Did I understand correctly that you're now working on the kind of solution business and moving towards the software as a service business, or are you already there? So where on the kind of your company journey are you?
It's not a kind of a journey, but a portfolio of our company. Yeah.
What about Peter? Your focus on different technologies. I've seen that you've been recruiting a lot of computer vision experts lately.
Yeah, computer vision indeed is one of our focus areas, and obviously we also have similar elements related to SaaS types of activities and then solution and services types of activities. But yeah, computer vision, NLP, there's a lot of these, I guess, standard use cases in computer vision. We're working a lot with autonomous vehicle vehicles in various forms, including self-driving cars, including autonomous vessels, including, say, heavy machinery and so forth. Maybe sort of looking at it a little bit more from a technology perspective, where I think we are creating the most value at the moment is, I mean, these standard use cases, object detection in computer vision is something that, you know, most can do with a standard library out of the box at the moment. Then, you know, we still have a very down-to-earth view to AI and what we can actually do today. You know, most of the value created is done through supervised learning, and where that puts the bottleneck in most cases is around data issues. And that's what we focus on in most cases, so how you can sort of speed up that process and improve the quality of the underlying data and eventually get started with actually creating, say, computer vision-based models. So that's really, I think, where we are sort of extending at the moment in bringing in various technologies that sort of extend what you can do with supervised learning and speed up what you can do with supervised learning at the moment.
Going back to the kind of future and trends, do you kind of see any specific trends now, technology-wise, merging?
Yeah, of course, we detect a couple of trends in the technology, but the important thing is that the time frame which technology will apply to the business needs, right? So in that meaning, I think the dialogue-based software, like a chatbot or a voice command like type of stuff, is definitely the big trend and yeah, huge market. That will become the huge market in the future, near future, I think. But it's not the technology, not only the technology, right? Because in academia fields, many innovation is occur every day. But which technology will deploy to the market? That's a more important thing.
So you're kind of guessing that we're still going to see a lot of kind of this basic tech. Did you mention chatbots, or what was the thing that you mentioned earlier? So very kind of humble still solutions that kind of off-the-shelf products almost will still grow as kind of the hardcore stuff will be still harder, I guess, to summarize your point.
Yeah.
What about Peter?
Yeah, so continuing a little bit from where I ended earlier, I think there's a lot of new technologies allowing us to do new things, and you know, there's examples like say active learning allowing us to sort of teaching solutions quicker. There's say transfer learning allowing us to move from one problem to another quicker. Various ways of making use of reinforced learning. Not sort of end-to-end, but rather in sort of helping your supervised approaches to learn better in certain environments where you're getting feedback, and so forth. So indeed, I think you know, I think there's a lot of opportunities in various technologies, even though they aren't giving you sort of this AGI or super intelligence at the moment.
Let's not go there.
But yeah, and then when you look at different sectors, then obviously different sectors and segments are at different sort of maturity levels at the moment, and I think this is what Uenoyama also hinted at. So you know, say where we are seeing a lot of movement at the moment is sort of say device level sensor-based solutions where you are sort of measuring, you're getting high quality data, and you're often sort of close to the measurement point in terms of putting your solution as well. So putting intelligence into devices, and device could be anything from say a mobile phone to a vessel.
I'm gonna ask you to continue on that. So you mentioned the kind of smart devices and kind of moving bigger machines, I guess. Any other segments that your companies are focusing on?
Our business focuses on existing device. We will not design a new device by myself, because cost of the computing and the cost of the device is really important to creates a business, right? And smartphone and home devices, and these GAFA develops this type of the product through the term of the investment in the globally, right? So we will focus on the software base, mainly focus on the algorithm layers, maybe partially integrate the third layer, but focus is really important. So we will thinking deeply which type of software will flourish in near future on the existing device, like the AirPods or home device or smartphone, like that. So this type of a view, yeah.
Let's talk about growth. Of course, when was your company listed?
Huh?
When was your company listed? It was...
It was 2017, 3 years ago.
Yeah. So I guess you've been, of course, growing quite steadily. So what kind of growth expectations do you have for 2020?
Yeah, expectations are really high. Yeah. But our company's PEL is around the 200, but the fact is that the average PEL in the mother's market in Japan is more than 100. So high pressure is not for my company only. Maybe in Japan, emerging company average PEL is around 100. So yeah.
What about Silo?
Yeah, we're obviously at a little bit earlier stage, having sort of 2 years behind us at the moment, and you can probably remember those days, and I guess growth being something simpler to talk about at that point. So we've doubled our team in the past, say, 6 months or so, and that is sort of what we are focusing on at the moment as well, but obviously, sort of a lot of that comes from the focus areas and the segments that we have at the moment, and the way that we've been sort of pushing through in the market. And I think the fact that the market is sort of also getting more and more mature helps us along the way. So indeed, I mean, moving from sort of hand-waving around AI projects and doing sort of innovation POC projects to actually being involved in some sort of large-scale implementation projects where you're sort of actually creating competitive advantage to others in their sort of core products, then allows you actually to sort of create a larger business out of that. And I think that's where we are at the moment in the sort of customized AI product solution market. Yeah, but I don't know how you are seeing it in Japan. Maybe it's different compared to the Nordics.
Is it? Well, you don't have to answer that. We can go through we can answer it through different questions, of course. So what I'm thinking of is, Peter, that you mentioned the kind of AI readiness level, or the readiness level to adopt different AI solutions. You said that the market has been maturing. What do you feel as are the main drivers behind that? The market is getting kind of more ready for AI solutions.
Yeah, so I mean, there's certainly 2 or more, but at least 2 things that are impacting this. One is what we are doing, and I think we've been learning along these 2 years quite a lot where to focus and where not to focus, and that's obviously causing a bias in sort of this interpretation. But at the same time, yes, indeed, obviously, companies are getting more mature. They're getting sort of competencies in place. And in that way also sort of able to develop own AI-based products, and that's where I actually see sort of the value at the moment. It's not really about AI. It's not really about sort of having an AI product. It's really about having sort of conventional product development projects in place or programs in place, and being able to plan out those AI components within those sort of large programs. And I think that's where you are sort of truly creating value at the moment.
So going from small POCs to be actually be part of the R&D process and the product development.
Yeah.
If we're thinking about which type of AI should be deployed on the client, one way to think is that the type of the AI for type. One is AI on the web is a kind of recommendations or some NLP kind of stuff. This is the first phase that's easy to deploy because all operations already digitalized, right? And the second is that enterprise AI, which is replace those traditional enterprise softwares to the switch to the third type of the software with algorithm. This change is slightly happening in Japan now, and maybe it depends on the country, company, and the country maybe. And the third phase is that recognition AI, which is largely driven by the deep learning, like a voice recognition and image recognition or generation type of stuff. And the last thing is that autonomous AI, which is not only the software but also the built together with actuators, like autonomous car or robotics type of stuff. This four phase is totally different, I think. So if we're thinking about how to deploy the product for the market, this perspective is one way to think about. It might be.
Then let's still be focusing on kind of the sales and growth. Peter, as I said previously, you mentioned that the market is getting kind of better in many ways. If you can kind of talk about on a general level, what do you feel are still the kind of the basic bottlenecks that prevent us from seeing even more AI-driven solutions there?
Yeah, I think a lot of that relates to. At the moment, I think a lot of that relates to competencies. I think organizations need to build out their competencies in order to be able to build, even though they're buying, just buy sort of AI-based products or services. And at the same time, I think it's been sort of a natural timeline. 2017, not much was happening here in the Nordics. 2018, a little bit innovation projects, POCs, and so forth. And now you are seeing more and more sort of true product development programs being set up. And then, obviously there's data bottlenecks here and there, but I think that's more of a technical issue. And I'm sort of pretty confident that sort of time will take care of that.
What about in Japan?
In Japan,
so what are the kind of bottlenecks that you're facing with your customers that they are not able to maybe deploy AI solutions on a larger scale?
Larger scale. Of course, the traditional company and their have their, how can I say, conservative company and the conservative industry have the existing rule for software and this rule is how can I say, I say that AI and web or this type of software and existing traditional software is totally different. So if big company treat two types of software in the same thing, that definitely is a bottleneck because traditional software has a lot of the rule for deployment and how to use and security kind of stuff. So this means understanding of the CEO of the company is definitely affects to the deployment of the algorithm software. Maybe that's the same in Finland, I'm not sure. But.
Yeah, I guess so. What about competition? Are there any other kind of AI companies listed in Japan at the moment?
In Japan, not so. Many investors ask me that who is a competitors. Yeah, but our answer is that we will disrupting the existing software business, like IBM or Hitachi or NEC kind of stuff. So, of course, they are a competitor, but they are already in the dilemma of innovations. So this is a market opportunity for us. So we will start to disrupting this huge market. So they are a competitor, but market opportunity at the same time. So these days, a couple of the small companies will start in Japan. Yeah, but we will not compete each other because a huge market exists already. Yeah.
What about Silo?
Yeah, no, I would agree that the market at the moment is pretty big and the market is growing. And when you are in a market that is growing, then obviously there is space for several players. And but at the same time, I think still I think competition for talent is big at the moment, and I'd say again, as previously said, competencies being one of the main factors as a bottleneck. I think that is also sort of one of the competitive advantages that you have to play with when you are working in this space. And I think that the challenge for many of the sort of incumbents coming into this market with sort of existing traditional operations in, say, software services, do have a little bit of a challenge in actually making sure that they have interesting enough work for, say, senior AI researchers coming from academia, having spent, say, 20 years, 15 years working with these technologies. And I think sort of that is also one of the value propositions that we are focusing quite a lot on. So when you work with Silo, then you get to work with some of the most advanced technologies and be involved in projects that sort of give you a view into what is happening currently in, say, Europe, in Asia, in the US, in some of the leading AI development programs. And I think that is, at the moment, the crucial element there.
Yeah. At this time, I see that the clock is ticking, but I would like to open the floor for questions. So there's immediately one. Great stuff.
Hello, my name is Peter, Aalto Uni. Thank you for the discussion. I would like to raise an issue about this gap you raised between the AI solution and the AI deployment. So how big is your role in consulting, AI consulting? How much human resources you spend on that? Because one thing is having the product and another thing is to convince the company to actually deploy it, because it actually can change the whole processing pipeline of the industrial partner. So what's your take on that?
Yeah, so I think that's crucial, and I think there's no one answer to this question. Pretty much every single organization looks a little bit different, and every single architecture and infrastructure requires probably a little bit of a different approach. What I do think is crucial is that when you are initiating a product development initiative, that you do from the very beginning account for the requirements that sort of, say, a machine learning based component will have on the data architecture that you have, on the sort of computational resources that you need, and so forth. So what we literally see in many cases is that sort of we are brought in when, say, the app has been developed already, or when the sort of physical product has been developed already. And then you should somehow sort of sprinkle that AI on top. And that as such is difficult. But then sort of how you integrate, in many cases it does require sort of services, you said consulting, I do think that is an element that is quite difficult at the moment to take out. So sort of only putting forward SaaS components that perfectly integrate with every single company's processes, I do think is a challenging element at the moment.
Any other questions? There's one in the back.
Hi, my name is Sailesh. What do you think about the legislation part and how easily they can wrap the things because you said you approach the Softbank, your PKSHA technology guy. So usually technology always leads, but the legislation always lags. So how do you bridge both the things?
What? How to compete with the Softbank?
So could you maybe repeat your questions?
See, the thing is, technology existed all the time. It's not the technology, it's a service legislations, agreements level. When you go to the operator with the ARPUs and all this thing, according to the legalities and all this thing, how quickly the people can come on to the ecosystem. So when you see, one of his presentation, it says algorithms and the robots, that's a kind of a migration we are going in. Well, we call it as ubiquitous. That's where we are arrived. So how quickly the legalities and the legislations can be adopted so it will be turned into services. What is the duration or do you have any kind of timelines or something like that?
So I guess, did I understand you correctly that how fast will we see legislation actually affecting our businesses?
Yeah.
Do you have any point of views on that topic?
How to?
No, I think that legislation as such is a big topic, probably a panel of its own. But I think in a sense, if we are now looking at sort of the Nordic perspective here, then certainly when it comes to data-related issues, GDPR and so forth, we've been in a sense at the forefront of many discussions. I'm not seeing that much of an impact of that at the moment, but at the same time, I think it puts us on a sort of say more stable or sustainable path towards some of the future issues that we will be facing, and I think legislation will have an impact on several of the sort of ways that we can make use of these technologies in the future, say based upon computer vision and so forth. So.
All right, great. I see that Klaus Mikko is look at me with a very angry face. I guess we have to stop now. But please give a big hand for these two phenomenal entrepreneurs.
Thank you so much. My angry face. But good, no. Thank you so much, guys. So that was the discussion. Thank you so much. So we're discussing the trends and the building and the commercialization. Now we're going to have more or less, thank you so much on behalf of NordicNinja, Finnish Center for Artificial Intelligence, and then Finnish Artificial Intelligence Accelerator FIO. So, and of course, Helsinki University and Aalto University for helping out. So hopefully this will more or less build out, linking up our friends from Japan. If the delegation members could rise up your hands, all of the delegation members from Matsuo-san, so they are here in the middle, so feel free to come over and mingle. They cover massive amount of different areas of expertise, so hopefully we can link and build on those relations from a Finnish, Nordic, European point of view. So thank you much for that. We will now have 1 hour break for networking. We will continue with the delegation and those interested at the corner in direction of my hand called Fönster. We're going to have 2 case examples, which is the elements of AI, more or less the platform for open AI education, aiming for the 1% of European people to be educated within AI, and then Mass Global, one of our NordicNinja portfolio companies, introducing how are their goals and activities related to AI as well. So that's from 4 to 5 p.m. there in the corner room as well for further discussion. Without further ado, there are now coffee and some snacks all around available. So thank you so much, and Hope you have an excellent evening. And as mentioned, if anything, AI trends is the hashtag, and you can find the material very soon at nordicninja.vc/AI. Good. Thank you so much. Thank you, Tiedekulma, Think Corner. Have a great afternoon, everybody. Ciao.